Welcome to our webinar on manipulating gain in feedlot cattle with Heidi. My name is Alex Centeno. I'm the Ruminant Marketing Manager for North America at dsm-firmenich, and I'll be your moderator today. First, let's go through some logistical details. Note that this webinar is being recorded. The recording will be shared via email with all registrants later today. You can ask questions at any point using the Q&A button at the top of your screen. And we're going to cover as many questions as possible at the end of the presentation, but if we run out of time, we'll follow up with you after the presentation. All attendees are anonymous, but if you do ask a question, know that your name will become available with your question unless you submit it anonymously. Today's webinar is focused on Heidi, which is approved for use in cattle in the U.S. To find out about approved use of Heidi in markets outside of the U.S., please contact your local dsm-firmenich representative. Today's presentation will include ROI calculations. The prices used in these calculations are for illustrative purposes only. So for any questions on Heidi pricing, please contact your dsm-firmenich representative. Now, let me introduce today's presenter, Dr. Zeno Hubbert. Dr. Hubbert began her career in the animal feed industry in South Africa after obtaining her MS degree in dairy nutrition from the University of Pretoria. After gaining 10 years of experience as a commercial nutritionist with involvement in central formulations, feed milling, research, and technical consulting, Zeno relocated to the U.S. to obtain her PhD in feedlot nutrition at New Mexico State University. Her research focused on investigating the relationship between liver abscesses and the microbiome of feedlot cattle and their environment. After completion of her studies, Zeno worked as a global feed specialist in innovation with Nutreco in the Netherlands, after which she joined Kevin, as Senior Product Manager and later Strategic Marketing Lead, overseeing the ruminant portfolio. Zeno joined dsm-firmenich in 2024 as a ruminant technical expert. Dr. Hubbert, welcome, and the floor is all yours.
Thank you so much, Alex, and welcome to everyone joining us this Friday morning. I think anytime we can talk about feedlot nutrition is a good day, so let's get started. Today we're going to be talking about Heidi, or really we're going to be discussing optimizing vitamin D nutrition in our feedlot cattle. But I'm going to start this discussion by focusing on the problem first, and then we'll make our way to potential solutions and ways to mitigate that specific problem. But all in all, Heidi, I want us to kind of set the stage from the beginning. Heidi is a product that contains 25-hydroxy vitamin D3. It's a circulating form of vitamin D in the animal. And there's 4 components to Heidi in terms of its activity or mode of action in the animal. It's a unique and immediate source of vitamin D available to cattle. There's research supporting the fact that it strengthens the immune capacity of the animal. There's data supporting enhanced muscle growth, and then overall that results in increased profitability. For those on the call that's not familiar with dsm-firmenich, our company is the #1 global feed premixer in the world with over 50 premix plants across different continents. Just here in North America, we do have a facility in Canada, Cambridge, Ontario, and then also a facility in Ames, Iowa, Pendergrass, Georgia, and Fort Worth, Texas, where we also produce our dispersible liquid concentrates out of here in the US. So over the years, since the 1900s, dsm-firmenich has changed names a number of times, but what's stayed consistent over these years is the commitment to improving the recommendations for vitamins in cattle, all species really. And ever since 1952, there's been a set of recommendations that's been published on an annual or biannual basis into the industry to guide nutritionists in terms of which vitamins they need to supplement and at which specific levels as well. So end of 2022, the latest OVN, Optimum Vitamin Nutrition Concept recommendations were released into the industry. And that also is used hand in hand with the NRC or NASM recommendations when nutritionists evaluate their rations for vitamin optimization. Let me advance there to the next slide. Then also a really good resource I can recommend to all nutritionists to have on your bookshelf is this OVN ruminant book from DSM. Now, this book was published end of last year, and it's really a compilation of all the research available today in terms of vitamin nutrition for specifically beef and dairy cattle. It's got information related to digestibility coefficients, absorption, bioavailability. So definitely get in contact with your DSM representative to find a copy, digital or hard copy of this resource. You'll also see this is an example of the OVN recommendations. I'm not going to discuss recommendations now. We'll work our way towards that in the end. But again, these are the resources available when we evaluate our rations for vitamin optimization. Just briefly, when we talk about the OVN vitamin nutrition concept, it really stands for Optimum Vitamin Nutrition Concept. Now, these days, or really historically, there's been a lot of focus to keep animals out of that deficiency category. But if we look at the way that we feed cattle today, very few of our animals are truly deficient. So when we feed beef cattle, we are striving not just to get them out of that marginal deficiency category. We want to optimize gain. We want to optimize immune health. And that's where the OVN DSM vitamin nutrition concept comes in. Not only are they trying to keep them out of deficiencies, but it's very much focused on which levels we need to supplement to optimize immune health as well as productivity response. And in some cases, even at a higher recommendation, when we talk about vitamins such as vitamin E, for example, where we want to extend the color case life of meat. So yes, again, we have our NASM recommendations, work very closely hand in hand with our OVN vitamin recommendations as well. And all of these recommendations, of course, focus and based on research collected to support those recommendations. So now we're going to start talking about a problem that I think we all are aware of in our feedlots today, not just in North America, also in some of our other countries. Number one problem potentially is stress. Stress affects all cattle and all production systems. We know that it's probably the major health challenge today in beef cattle. And we're going to discuss how it potentiates disease through altering the immune status and then also having that knock-on effect in terms of an inflammatory response. We know that that receiving calf that's received at the yard is exposed to various levels of stress. Not only do we transport that animal over long distances, some of them comes out of a sale barn, we process them, we sort them, we commingle them. Sometimes we make changes in terms of our feed bank management and feed delivery. We're thinking about inclemental weather, not just high temperatures or high humidity, but also cold and mud stress. So all of these stressors impact that animal that's already immune compromised when it arrives at the yard. And then we all know that probably the number one health challenge we deal with today in our feedlots is bovine respiratory disease, a complex multifactorial disease, and today the leading cause of morbidity in our feedlot cattle. And there's been shown to be a strong correlation between all these stressors impacting that animal and the level of pathogens in the environment and the propensity to develop bovine respiratory disease as well. So what's the relevance of stress, this disease that occurs in our feedlot cattle? The relevance is that there's an immune response and that impacts feed intake and that impacts profitability over the entire feedlot period. So we want to talk about the mucosal immune system or the firewall response that the animal has. It's basically made up out of the mucosal epithelial cells. And these mucosal epithelial cells are not only present in the gastrointestinal tract, it's also present in the reproductive tract, it's also present in the respiratory tract of the animal. And together with commensal or beneficial bacteria, we then see that a first immune defense barrier or a firewall is formed that keeps out pathogens and prevents pathogenesis as well. However, when we have a stressful situation, for example, or different challenges, it can also be physical or high levels of pathogens in the environment, that immune defense barrier is challenged, and we then have a situation of dysbiosis. One thing that comes to mind is leaky gut. That we know very well of, but the same situation can occur in the respiratory as well as the reproductive tract of the animal. And there's actually been data that shows or supports this notion that there's an interaction between the host and the mucosal microbiota in the bovine respiratory tract. So very important for us as nutritionists and veterinarians to try and maintain that mucosal epithelial cell barrier of the animal, as well as a stable state in terms of the commensal bacteria. So what does this mean in terms of productivity? So when we have a high level of pathogen in our feedlot environment, so for example, when our receiving cattle is received into the yard, they stress, they challenged by pathogens, we then see our lymphocytes and macrophages release cytokines into the bloodstream, which then would prompt the liver to have an acute phase protein release or acute phase protein response. And we know that those acute phase proteins is related to high levels of neutrophils in the blood. We see a febrile or a fever response as well, and that also results in a depression in feed intake. And anytime feed intake is depressed, we know we're going to see an impact on morbidity and rate of gain as well. So I hope I'm able here to illustrate the impact of stress, pathogens, and how that relates to this inflammatory response. And in effect, as nutritionists, we try our very best to mitigate that inflammatory response at the end of the day. So just briefly, I'm sure everyone on this call is well aware of the impact of BRD to our industry. It's costing us today about $1 billion on a yearly basis to our industry. To treat one of those animals for BRD, it's about $214. This is all research that's been published. 3 times treatment for BRD is about $385. And we know that about 97% of feedlots are reporting incidences of respiratory disease. So definitely the number one economically important disease that's challenging feedlot productivity today. So then there's various ways that we can mitigate animal health in our industry. Today, we're going to be focusing on nutrition, specifically on vitamin optimization, and look at some research that supports mitigation of morbidity in the feedlot. So we're going to discuss specifically vitamin D optimization in our beef cattle and how that would improve the immune response in the animal. But first, I want to take a look at metabolism of vitamin D. Now, everyone's aware that our feedlot cattle in the US, nearly all of them are exposed to sunlight. And there's this notion that with sunlight exposure, there's adequate vitamin D status in the animal. And we'll look at some data that shows that that's not necessarily correct. So we know that in the skin, the 7-dehydrocholesterol can be converted through UVB radiation into vitamin D3, also known as cholecalciferol. We also know that there's vitamin D3 commonly supplemented, let's say as per NASM requirements or recommendations in the ration. And that vitamin D3, together with the vitamin D3 constantly produced in the skin, would then have to go to the liver. Now, in the liver, we find an enzyme 1-alpha hydroxylase. That enzyme is not exclusive to the liver. We'll see later that we also find that enzyme in the kidney. We also find it in the macrophages of the immune system as well. But in the liver, vitamin D3, before it can have any impact on the animal, has to be hydroxylated into 25-hydroxyvitamin D3. As we mentioned earlier on in the discussion, 25-hydroxyvitamin D3 is what's contained in high D. So just making that link to high D as well. Now we've got vitamin D3, it's hydroxylated to 25-hydroxyvitamin D in the liver. What's important to note here is it's not merely a case of increasing vitamin D3 supplementation to our cattle to optimize vitamin D status overall, because there's a bottleneck that occurs in the liver. Specifically, Dr. Corvin Nelson's group at University of Florida did a lot of work in this area. This has not been quantified to the extent that we know exactly at what level that bottleneck occurs, but there's a lot of interesting research occurring in that area today. What we do know is there's a bottleneck. So then this 25-hydroxyvitamin D now is still not the active form in the animal. It's merely the circulating form in the blood. And that's also why when we determine the status of vitamin D of an animal, we measure the 25-hydroxyvitamin D3 level in the serum. So that's a generally accepted analytical measurement of vitamin D status in an animal, humans, all species alike. So this 25-hydroxyvitamin D is then transported to the kidney as well as to the immune system, the macrophages. Mainly in the kidney, it will be hydroxylated into the active, which is now the hormonal form of vitamin D. And this is called 1,25-dihydrocholecalciferol. It's this hormonal form that in the end is able to actually bind to vitamin D receptors. Those vitamin D receptors are found throughout the body on different tissue cells, such as the gastrointestinal tract and the muscle cells. It's been isolated on skeletal muscle cells as well. It's found on the bone and the kidneys. In addition to the kidney, what's very interesting is the macrophages are also able, because they also contain 1-alpha-hydroxylase, they're also able to convert this 25-hydroxyvitamin D into the active hormonal form of vitamin D3. In addition to that, in the macrophages, in response to this production of 1,25-dihydrocholecalciferol, they also are prompted to produce defense proteins, which actually has antimicrobial activity. So this is also work that's been published by Dr. Nelson's group. Very interesting. So there's a potential antimicrobial effect there in response to that 1,25-dihydrocholecalciferol production. We've discussed the metabolism of vitamin D. Usually when we talk about beef and dairy cattle, the focus with vitamin D optimization in the animals usually centered around calcium and phosphorus homeostasis. We do know that when there's a reduction in the calcium level, for example, in the blood, the body will respond. There will be an increase in the 1,25-dihydrocholecalciferol level, and then there will be an increase in the calcium level in the blood as well to maintain that homeostasis. But today with beef cattle, we're going to focus around the impact on muscle growth, muscle hypertrophy, as well as immune response in terms of immune cell activation. Later, we'll take a look at some data that shows the ability of vitamin D to upregulate very specific genes associated with the immune system. But basically, it's only the 1,25-dihydrocholecalciferol that's able to bind, as I mentioned, to these vitamin D receptors that's found on the cell walls, different cell walls throughout the body. And by doing so, they also bind to a retinoid X receptor. They're actually able to act as a transcription factor for gene expression of different genes throughout the body as well. Okay. So in essence, vitamin D optimization in terms of its role in immunity, that includes 1-alpha-hydroxylate acting on the immune cells and then locally converting that 25-hydroxyvitamin D3 to the active hormonal form of vitamin D3. We've seen that vitamin D3 receptors are present on not just only the immune system cells, skeletal cells, various different tissues in the body. There's also data that supports that vitamin D can actually stimulate the gene expression of specific toll-like receptors, TLR2 and TLR4, that's associated with these defense protein production. So again, that antimicrobial activity. So definitely a lot of research that supports that immune activity or that immune effect of vitamin D optimization in animals. And that data is across species as well. Here's a good example. What they did in broiler chicks is they looked at the level of 1-alpha-hydroxylate, that enzyme that's needed for hydroxylation of vitamin D3. And they found that not only in the kidney tissue, it was in the breast meat tissue, thigh tissue, the spleen, the liver. So one would assume to have a similar situation in beef cattle as well. I haven't seen that data though, but this is certainly interesting. So now we're going to take a look at some specific research data that supports this mode of action that we just described in terms of how vitamin D has an impact on immune health in cattle. This study, it's a swine study, but for me, it's really relevant when we talk about bovine respiratory disease today. We conducted this research study. It was a DSM study in collaboration with researchers from North Carolina State University, where we looked at 42 3-week-old weaned piglets. And in swine, there's a disease called porcine respiratory reproductive syndrome virus. a lot of similarities between that and BRD in beef cattle as well, therefore the comparison. So what they did is they had a 27-day adaptation period and then a 41-day supplementation period. And then there was different treatment levels, either with low, let's call it marginal levels of standard NRC recommended vitamin D3 levels, or a higher level of vitamin D3, or a higher level of vitamin D3 plus high D, this 25-hydroxy vitamin D3 in addition. And then they either challenged or didn't challenge some of those treatment groups with this PRRS virus. And then 2 weeks later, they took their measurements. So what came out of this research study, some preliminary results, is that high D supplementation clearly increased the PRRS virus specific serum IgM and IgG compared to the low and the standard group. So those low and standard groups only receive low and standard NRC levels of vitamin D3. We also saw an increase in the antibody production against this PRRS virus. For me, what's really interesting here is the impact on mortality as well as the histopathology scores of those lung tissues. And I'd like to see what happens in beef cattle as well. So with this high D supplementation, we saw a reduction in the mortality over that 14-day or 2-week period post that challenge period. And with vitamin D supplementation as a whole, not just high D, vitamin D supplementation, there was a reduction in the necrotic macrophage scores in those pigs that were challenged with the PRRS virus. Now, earlier on, we took a look at the mode of action of vitamin D in terms of its gene transcription ability. This data definitely supports that mode of action. This was conducted by Dr. Nelson and Santos's group at University of Florida. They worked with transition cows, and there was a treatment period 30 days prior to calving, and then they took their measurements up until 3 days post-calving. There were 4 different treatment groups, 1 milligram of vitamin D3 supplementation and 3 milligram of vitamin D3, and then compared to either 1 milligram or 3 milligram of high D supplementation. What they saw during this study was, if you look at these green images, so we have the prepartum period as well as the postpartum period. The green images signifies an upregulation of the genes associated with these specific aspects related to the immune system. So with high D supplementation, either at 1 milligram or a 3 milligram level per head per day, we saw an increase in the gene expression associated with cell adhesion and migration, pathogen recognition receptors, antimicrobial mechanisms, really important, as well as calcium metabolism, just to name a few. So the conclusion of this research study was researchers noted that supplementing 25-hydroxy vitamin D3, which in this case was high D, provided an opportunity to alter the leukocyte machinery to harness the immune responses to fend off infections in animals. So in addition to that study, that same research group at University of Florida conducted an additional research study also with transition cows. It was a combination of primiparous and multiparous cows, and they supplemented them for this 3-week period prior to calving, but then they followed them through until 50 days of milk. There were 4 different treatment groups, either 3 milligram of high D or 3 milligram of vitamin D3, with either a positive or a negative D-cation anion difference diet. So the conclusion of this research study was that high D supplementation, 25-hydroxyvitamin D3 supplementation, increased the neutrophils with oxidative burst energy. And that was almost a 9% difference. It also reduced the retained placenta levels in those transition cows. We saw a reduction in the level of metritis, as well as a reduction in the overall level of metabolic disease during that early lactation period. During that same study, the researchers also evaluated the impact on colostrum content and quality. And with high D supplementation, we see an improvement in the IgG content of that colostrum, as well as the true protein yield of that colostrum as well. And later on in the discussion, we're going to take a look at how we can actually manipulate the vitamin D levels in the colostrum or in the milk itself through supplementation of that gestating dam as well. So just looking at this colostrum quality, that fits in well with our discussion later as well. Now, this research study was conducted not with transition cows in this case, also by the same University of Florida research group, but they used here cows that was at least 110 days in milk, and then they either provided them 1 or 3 milligram vitamin D3 or 1 or 3 milligram high D or 25 hydroxy vitamin D3 for a 28-day period. And then, interesting, at the 3-week period, 21 days after starting that research study, they challenged them with Streptococcus uberis. And then took their measurements. So what we saw here is when supplementing high D to these cows, we were able to mitigate the severity of this mastitis infection. And this is evident in the increase in the mRNA transcripts abundance for the interleukin-1 beta and the INOS level in the somatic count of those cows that was challenged with the Streptococcus uberis. We saw a reduction in the mastitis severity and overall an increase in the gene expression of vitamin D responsive genes as well. So with this vitamin or 25 hydroxy vitamin D3 supplementation, we were able to alter the immune response of these challenged cows to infection. So again, the question is, what would we see in a feedlot situation considering this data? So this research study was conducted in Denmark, where they used 24-day-old Holstein cross calves. And it wasn't conducted by supplementing high D. This was purely looking at the impact of vaccination and what that impact is in terms of fluctuation on the 25 hydroxy vitamin D3 level in the plasma of that animal. So they had a vaccinated group against Mycobacterium bovis and a non-vaccinated group. And then the vaccination phase lasted from day 0, which was really day 24 for those calves, up until week 52, where they infected them with Mycobacterium bovis and then took their measurements up until week 65. So what we saw there is that the serum 25 hydroxy D3 level increase in the vaccinated versus the non-vaccinated calves after infecting them with the Mycobacterium bovis. There was also a negative linear relationship between the lymph node pathology score of those calves and the plasma 25 hydroxy D3 level, irrespective of the vaccination status. So we've taken a close look now at vitamin D's role in immune health. Now we're going to transgress or move on to what role vitamin D supplementation or optimization may play in muscle hypertrophy. We're going to take a look
Zeno,
at the... Yes.
Dr. Hubbert,
Alex.
I just want to give you a quick pause and remind our audience that you can submit questions at any time using the Q&A button. And remember, you can submit them anonymously or publish your name. It is completely up to you. We received a couple of questions so far, but wanted to share that reminder with our audience. Do not forget to ask those questions. All right.
Perfect.
Back to you.
Thanks, Alex. So we're going to take a look at the AKT or the mTOR, mammalian target of rapamycin signaling pathway in the skeletal muscle tissue. And then we're going to see how IGF-1 and insulin impacts muscle hypertrophy within that mTOR pathway. And we're going to take a look at what impact vitamin D in the form of its active form or hormonal active form 125 vitamin D3 has in terms of sensitizing that mTOR pathway to insulin and IGF-1 growth factor to then have a positive impact on muscle hypertrophy. So as I mentioned, we're going to discuss the mTOR pathway. Here we just see how 125 vitamin D3 is able to then sensitize this mTOR pathway to the impact of IGF-1 and insulin through binding to the vitamin D3 receptors on that cell wall. And as I mentioned earlier on in our discussion, vitamin D3 receptors have been shown to be present on the cell wall of these skeletal muscle tissue cells. Now, we're going to take a look at satellite cells and how that impacts muscle growth. We know that when animals are born, and same as in humans, our muscle fiber number are set at birth. So there's nothing we can do to increase the number of muscle fibers and then have higher levels of weight gain. So postnatally, the only way we can hypertrophy or increase the size of those muscle fibers is by focusing on increasing the nuclear material that's donated from the satellite cells. But satellite cells is also present in a quite small percentage, between 3 and 10% in skeletal muscle tissue, and that also decreases as the feeding period goes on. So there's also some question as to when is the optimum period that we can actually manipulate these satellite cells. And I don't know how many of you were on the previous webinar we presented with Dr. Brad Johnson from Texas Tech University, and that's work that his research group is currently focusing on to see exactly where we can manipulate those satellite cells. However, these satellite cells are able to donate DNA material to the muscle fibers and fuse with those muscle fibers, and then that results in muscle hypertrophy or an enlargement of those fibers, and that's really hot carcass weight gain, more meat, more gain. So now we're going to take a look at some HIDE data that supports an impact on that gain. First, I'm going to share briefly with you some research in broiler birds. A large part of the industry is also supplementing or optimizing vitamin D in their birds with the focus on increasing breast meat yield. So what they did in this specific study, they had a controlled diet with industry standard NRC levels of vitamin D3, and then they also had a treatment group where they supplemented additional HIDE or 25-hydroxyvitamin D3. What they showed in this study is that HIDE supplementation was able to stimulate satellite cell activity in muscle tissue, and that's evident by the increase in the MyF satellite cells, as well as an increase in the larger muscle fiber cross-sectional area of those of that muscle tissue. And we're going to see similar data in beef cattle that perfectly aligns with what we see not only in broiler birds but also in swine when supplemented with HIDE. This is an additional study that's been published also with broiler birds, where they had varying levels of vitamin D3, supplemented HIDE on top. They either supplemented HIDE, only took those broiler birds, or supplemented up until 21 days in the growing period, and another treatment they supplemented up until the 40-day period. And then they were also able to concur with the results of the previous study where we saw that increase in satellite cell expression, but they also measured here an increase in vitamin D receptors expression in the breast meat tissue. So this really supports that mode of action we discussed in terms of vitamin D optimization or sensitization of that mTOR pathway. Now, this research study is beef cattle, and it was published in May of this year. It's a study that was conducted at the University of Sao Paulo. Again, we're going to be sharing some data here. It's being conducted with Nellore cattle, so when we get to the Q&A session, we can answer some questions in terms of how we make a comparison between different cattle types and our U.S. cattle types. But this research study was conducted with 120 intact Nellore bulls. We know that in Brazil, we don't use implants, beta agonists, so there's a difference there. We fed those animals for about 96 days, took them from 830 pounds to a very familiar 1,126 pounds. So we can draw that comparison to our US conditions. What we saw there is they did a similar analysis of the gene expression in the satellite cells on those skeletal muscle tissue. And we saw with HIDE supplementation at 1 milligram per head per day, we were able to linearly increase the IGF-1 expression in those skeletal muscle tissues. We also saw an increase in the IGF-2, as well as the mTOR and myostatin expression in that tissue. And that went hand in hand with an increase in the dressing percentage, as well as a hot carcass weight. Now, dressing percentage is subjective to some extent, but I like to take a look at the hot carcass weight because we know that's what matters. Of most importance to our producers. In this specific study, we were able to detect a 10-pound. Yes, the study was most likely underpowered, so we will not see that in the p-value here, but definitely a numerical difference, a 10-pound difference in hot carcass weight when feeding that 1 milligram 25-hydroxyvitamin D3. And just to note that our current recommendation for HIDE is set at 1 milligram in growing animals. Very briefly, I'm going to talk about what our vitamin D status in our cattle is today. There's been numerous surveys conducted. Again, I believe Dr. Nelson's group did a great job in trying to narrow down what the optimal levels to support productivity and immune response needs to be in cattle. And that's what we're looking at now. We have those deficiency categories for vitamin D or 25-hydroxy-D3 levels in serum. So anything below 5 nanograms per milliliter, we consider that animal to be deficient. When we talk about beef cattle, again, we want to talk about optimizing performance. We're not interested in just getting out of that deficiency category. So to optimize performance, we want to be at least 100 nanograms per milliliter. A lot of this work has been conducted, I'd say it's probably skewed a bit towards dairy. So there's still some work being done to determine exactly where that optimal point needs to be to maximize growth and efficiency in the feedlot in terms of vitamin D optimization. So currently we're working with that 100 nanogram level in the blood as our target or our baseline. So there's been a number of surveys conducted to look at what our cattle status is. Looking at the values for our cows in the summertime, it's coming in at about 75 nanograms, 25-hydroxy-D3, dropping down with about 10 units in the winter to 60. Calves lower at 48 in the summer, down to 11 nanograms in the winter. So definitely just adopt that efficiency category, but not adequate yet. Now, when we look at feedlot data, there's a lot of variation. It depends on where those animals come from. It depends on the shipping time of the year. But overall, we see them in the summer to be able to reach that 100 nanograms per milliliter threshold, and then dropping down in the winter time to that 32 nanograms per milliliter. So definitely not supporting optimal growth and performance. There's some additional data was presented. You can see this normal distribution here. Overall, if we look at beef cows specifically on pasture in northern and southern regions of the US, we see that we average at around 65 to 70 nanograms per milliliter, and that's also dependent on the season. What I want to bring across, so there's some interesting data showing that we're actually able to manipulate the vitamin D status of a calf because there's a strong relationship, at least a 0.8 R-square of 0.8 relationship between the serum 25-hydroxy-D3 status of a calf and that of its dam. So by optimizing the vitamin status of that gestating cow, we can have a direct impact on that newborn calf as well, because we know at birth they are deficient in vitamin D. We also have some data, and I can share that later, showing that milk overall can only supply about 50% of the NRC recommendations or requirements for vitamin D in our cattle. Now, this study was conducted by the group from Clay Center in Nebraska. They had two different groups of steers, one in 2011, one in 2012. And what they did is they followed them through over different periods up until when they were born, summer, winter, fall. Once they hit the feedlot was their last sampling point as well. So during period 1, those steers analyzed at about 26 nanograms of per milliliter of 25-hydroxy vitamin D3, definitely under our optimal level of 100 nanograms. Period 2 was when they were about 6 months of age, late summer. So a lot of sun exposure. So we can see that vitamin D status increased to about 55 nanograms. And then about 3 weeks later, they did another measurement with another increase in the vitamin D status. And then when they sampled those animals in the feedlot in the middle of the winter, they analyzed at below 20 nanograms per milliliter. And it saw that about almost 30% of cattle that's placed in the feedlot today is analyzing at below 10 nanograms per milliliter. So those animals, as we discussed, are severely stressed already. We need to do everything we can to optimize that vitamin status to then support not just immune health, but also that growth response over the entire feeding period. This was a small pilot study at DSM we conducted with researchers at Kansas State University. We actually put a truckload of heifers on a truck and transported them from Dixon, Tennessee to Manhattan, Kansas. And we were able to see or to show that there was almost a 30% reduction in the 25-hydroxy vitamin D3 status of those animals post-transport. So just that mere act of transportation resulted in a 30% reduction in that vitamin D status of that animal. And then the question comes up, what does all the other stressors do? So what is the impact of commingling or processing, in addition to just transport stress, to the vitamin D status of our receiving cattle? Very briefly, our go-to method for determining the status of vitamin D in our animals is it's done through LC-MSMS analysis. We're targeting that 100 nanograms per milliliter in the blood with the serum. And we obviously use 25-hydroxyvitamin D3 as our indication of vitamin D status. Earlier on, we discussed there's quite a few different recommendations for vitamin D levels or vitamin levels overall in our cattle rations. Just comparing in the feedlot finishing phase, in the feedlot period, the NASM recommendations for vitamin D, which is set at about 275 IUs per kilogram dry matter, let's say almost 3,000 IUs per head per day. Comparing that to the Feedlot Nutritionist Survey that was published by the group from New Mexico State in 2016, we see that today our nutritional consultants are actually supplementing about 50% of the NRC recommendations for vitamin D. Now, taking a look at our DSM-OVN recommendations based on research to support those recommendations, we are recommending a 1 milligram 25-hydroxyvitamin D3 in addition to about a 5,000 to 7,000 IUs per head per day. So definitely some variation in terms of what we are doing in practice today, what the NRC is recommending, as well as our OVN recommendations. I mentioned earlier how milk's not able to supply, it's only supplying about 50% of the vitamin D requirements of that calf. So supplementation during that milk replacer, calf starter, calf grower period becomes really essential to make sure that we can deliver a calf to the feed bunk once it hits the feed yard that can perform from the get-go. Let's move on there. This is a research study that we conducted at a commercial yard in Kansas. Just a commercial study, but what this data showed us, we tried to depict the variation in 25-hydroxyvitamin D3 levels between different seasons. So we had 18 pens on the control diet where we only fed about 3,000 IUs NRC levels of vitamin D3, compared that to a high D treatment, 1 milligram high D per head per day. We had at least a 2-month supplementation period before we started taking our blood samples for determining the status of those animals. So the purpose of this study was merely to determine the status of vitamin D in those animals in response to supplementation. What we determined there is once you move from summer to winter between those two seasons, there's about a 74 nanograms per milliliter reduction in the 25-hydroxyvitamin D3 status of those animals. So that's a contribution of the seasonal change as well. With high D supplementation, we were able to maintain those animals at the optimal or above, well above the optimal 100 nanograms per milliliter baseline or threshold to support immune health and productivity. Similarly, we conducted a study with Kansas State University as well, with some very high-risk animals. Again, with high D supplementation, that's really all I want to highlight from this research study here today, was that with high D supplementation, we had an immediate source of vitamin D. So we already bypassed that bottleneck of the liver. We had the correct source that can then be hydroxylated further in the kidney and the immune system. And we were able to maintain that optimal level in those animals throughout the 56-day receiving feeding period of this specific study. So then lastly, I want to talk about profitability, and we're going to pull it all together now. We're going to take the impact of a high D in terms of the immune response, as well as the muscle growth response, and look at some of the productivity data that we can share with you. So this first study was conducted at the University of Sao Paulo again. It was also 120 nillorables. We fed them for 100 days, a 100-day feeding period. Also took them to about 1,129 pounds. We had a controlled diet with no high D. Also no baseline of vitamin E3 supplemented there. And then we were either feeding 1 milligram of high D or 3 milligram of high D. So no level of usual vitamin D3 in those 3 treatment groups. What we saw there is that with high D supplementation, we were able to increase dressing percentage and also a numerical increase in hot carcass weight. So again, in alignment with the study I shared with you that was published earlier this year, we see that 10 pound of hot carcass weight increase with this cattle. So if we look at the cost estimation here, we are looking at least a 10 to an 11 to 1 return on investment with that 1 milligram of high D supplementation. An additional research study conducted at University of Sao Paulo just confirms these results that we've just shared from the previous 2 studies. We also had 140 nillorables here, again, similar feeding period of 90 days. We had a control treatment with no high D, and then we had a high D treatment. In this specific study, there was also vitamin E added to that study. I'm sharing this because we're able to pull out the vitamin E effect here when comparing that with some other research studies that we have as well. But what stands out from this data set is, again, we have a return of investment with a specific data set of almost 10 to 1, a similar response in terms of hot carcass weight in that figure of between, I say when we look across all of our research studies, as low as 7 to between 7 and 10 is where we see that response in terms of hot carcass weight. There's an additional study that was conducted also at the University of Sao Paulo, and that corresponds to another study that I'll share later that Dr. Zinn actually conducted at UC Davis, where not only were we supplementing high D, it was really in the time period where we were still trying to find some kind of a substitute for monensin, which is not the case today. But looking at the specific data set, and there's a lot of information here, I'm more than happy to share this or have a discussion afterwards. But I just want you to focus on this response that we're able to pull out here from the high D supplementation. Again, here, at least a 7-pound response just as a result of high D supplementation in hot carcass weight. We also saw a nice dressing percentage response here as well. This is the research study that was conducted by Dr. Zinn. It was done with lightweight Holstein calves. We also see a similar response there in terms of hot carcass weight and numerical dressing percentage response. So then I'm going to move on real quickly. I have 2 studies left to share with you. Now, I mentioned earlier that historically we focus on the calcium phosphorus homeostasis response of vitamin D in cattle. There's one research project that was conducted by Dr. McGrath in Australia, where they had 18 rumen-fistulated Brangus steers, so more similar to the type of cattle we feed over here in the US. And they were feeding them a low-quality roughage diet. And then they had a control treatment that had no high D in that and a very high level of high D, so a 3.25 milligram of high D supplemented per head per day. So at day 0, they adapted them. They had about for 10-day adaptation period. And then at day 11, they put them into the metabolism crates and then took their samples up until day 13. So it was a 14-day treatment period overall. So what they were able to see here with high D supplementation of these Brangus steers, we were able to increase calcium and phosphorus plasma concentration as well as calcium and phosphorus retention. And then what we see here on the left-hand side is that 98% improvement in calcium retention, as well as a 63% improvement in phosphorus retention. This is one research study, so I would definitely not make a recommendation in terms of reducing your phosphorus level in your ration. Not at all. But it's definitely interesting in terms of what are we looking at in the future with additional research projects to potentially look at that phosphorus saving effect of vitamin D optimization in the animal, just considering the high costs associated with phosphorus supplementation today. Now, the last research study I want to share today is this one, again conducted by Michael Poindexter, one of Dr. Corvin Nelson's students as well at University of Florida. What they did here is we worked with heifers. There were two treatment groups, a control group where no Heidi was supplemented, and then the treatment group supplemented Heidi at a level of 1.7 micrograms per kilogram body weight. These were 143 Holstein heifer calves, and the supplements were provided both in the milk replacer as well as the starter feed. And all of these treatment diets contained a base level of vitamin D3 at 1.5 microgram vitamin D3 per kilogram body weight. So the treatment period was a 120-day period starting on at 2 weeks of age. And then what we saw with the Heidi supplementation, that there was an increase in the serum level of 25-hydroxy D3 compared to the control, as we would expect, and that's what we've seen in some of our other research studies as well, compared to the control. There was also an increase in the average daily gain of these heifers. So at age 16 weeks, we saw an 8.8 pounds, almost 9-pound response in terms of increased average daily gain, or 9 pounds heavier heifers at 16 weeks of age and 1 centimeter taller at wither heights. So that relates to an ROI of almost 34 to 1. This is based off one study. So obviously we would like to see some additional data to support that ROI. But just looking at the price of feeder calf prices today, that's about $25 back in terms of that 9-pound body weight response based on this study specifically. So definitely, again, we see a weight response, not only in the feedlot, during the feedlot period, but also some, I'd say, opportunities to improve weight gain in our heifers and replacement heifers as well. So that brings us almost to the end of our presentation, but I think we've now spoke about Heidi specifically as a unique and immediate source of vitamin D. We took a look at what the levels in our cattle are in the US today and how that varies significantly between seasons. And then we saw some data from commercial feed charts even showing that with Heidi supplementation, we're able to reach that 100 nanogram per milliliter, that optimal level in the blood for optimizing vitamin D status. We've discussed the mode of action of vitamin D in terms of how it strengthens the immune capacity. We also looked at some research data that actually supports that mode of action, specifically in dairy cattle. And then we looked at numerous research studies in feedlot cattle that shows how there's a hot carcass weight response. So that's centered around that mode of action of an increase in the muscle hypertrophy of skeletal muscle tissue in beef cattle. And then overall, we see that there is a profitability response of optimizing vitamin D status in your cattle. So with that, I think I'm going to hand over to Alex, and then, yeah, Alex will get us into any questions there might be. Thank you.
Wonderful, Dr. Hubbert. We did receive some questions from the audience. So first question, will the slides be made available to the audience?
Alex, I believe, yes, everyone that's registered will not have the slide deck, but you would be able to view the presentation afterwards. And correct me if I'm wrong, but we will share that after the presentation?
Yes, so everybody registered will receive a recording of the presentation. If you want particular slides, please reach out to Dr. Zeno. In that same email, you'll have her email information, so feel free to reach out and she can share any slides that you would like to see copies of. Okay, second question. In my small feedlot, we battle flies this time of year and see reduced feed time, stress, and disease risk transmission, for example, bacteria. Based on your slide on absorption and conversion in liver and kidneys, is it even more important to supplement with Heidi, especially during months of high insect impact?
I don't have any specific data related to the impact of stress, as a result of fly infestations, but what I am thinking, Alex, is with vitamin D or vitamin optimization in general, we tend to not only focus on periods of stress because it's so hard for us to predict when that's going to happen. What we've seen works best is to almost approach it as an insurance policy to make sure that animal has that baseline of vitamins in their ration on a daily basis. So not to only use it as a targeted approach to solve a very specific problem, because sometimes we might be too late. Because there's so many different stressors in addition to just the fly infestation as well. So as a nutritionist, I would always caution to rather make sure that we have the adequate level in the ration on a daily basis to make sure that animals are able to withstand any impact of any different stressors there might be. So certainly probably has a beneficial impact, but I think there's so many more stressors like we've seen that impacts that animal in addition to just the irritation from flies.
Okay, so you shared research conducted in Brazil with Heidi. What type of response do you expect in North American feedlot cattle with different implant programs and days on feed?
So we saw in Brazil that data shows about a 90 to 100 days on feeding period. Of course, here in the US, in Holstein influence cattle, we can go anything up until 365 days on feed. On our beef side, we're looking at about 180 to 220 days on feed. Also here in the US, we make use of beta agonists during that last finishing ration. And we also have an implant program. So we have access to those technologies. Now, it's a really good question, and it's one that I would like to answer myself, but we don't have significant or enough data yet to answer that outright. However, again, Dr. Brad Johnson's group is working on answering that question. And speaking with him, and I think he's covered some of that in the previous webinar as well, we believe there should be a complementary effect or an additive effect with high D or vitamin D optimization in addition to beta agonists and growth implants because of the mode of action of the product. High D is not a drug. It's a vitamin. It's just a different form of a vitamin. However, the way it works with the satellite cells and the muscle fiber types, it should be a complementary response. So it's not working to replace any of these other technologies we have access to. It's an additive response. So he believes, and we'll have to show that with research, of course, we should be at least be able to target that 10-pound hot carcass weight response. But today, I don't have the data to support that. Again, well, hopefully, I think, yeah, go ahead.
Hopefully in the future, that'll make a very interesting webinar to see those results from Dr. Johnson.
Yes. Yeah, working on that.
Last question. Can we expect any effect on marbling and tenderness of meat? I'm going to assume that this is assuming that you're adding high D into the diet.
And today, we don't have any data to support that. I think that's also a question we have to answer in conjunction with looking at our vitamin A levels. With the data we have today, we wouldn't expect a specific impact on marbling. That would also be dependent on the type of cattle we are feeding. I think that's part of a more complex answer looking at our vitamin A levels because the mode of action of those two are different in terms of how we can potentially manipulate marbling as well. So again, that's probably another webinar when we can take an in-depth look at marbling and how we can manipulate that with vitamins. But I think today with the level of vitamin D we're recommending here, it's not a drug. It's just optimizing the vitamin D status of that animal. We're merely trying to increase the sensitivity of those skeletal muscle cells to the impact of insulin and IGF-1 through supplying the active form of vitamin D in that animal in the form of 1,25-dihydrocholecalciferol.
Well, Dr. Hubbert, thank you so much. That was a very great and thorough presentation. And for all of our audience today, you will be receiving a recording of this webinar later today, along with the contact information for Dr. Hubbert. So feel free to reach out and sign up to subscribe for our newsletter and webinars by going to dsm-firmenich/anh-na for any future events we may have. Thank you for joining us today and hope to see you soon again. Goodbye.
Thank you.